Good morning, everyone, and welcome to the second part of the Power of Creo 10. Presenting today is, of course, Mikko Hinkkanen, and I will be your host and sidekick. And my name is Carolina Hay.
Okay, so welcome also from my behalf to this 45 minutes Creo 10 webinar on the Creo Parametric What's New. And today we will go through, well, the video introduction seems to be still there on the slide, but I just decided to push that to the end. So for those who can manage through the presentations, we will show that video introduction at the end of the presentation, which kind of then binds together nicely that what you've been seeing and how it's been developed in Creo for you. But the rest of the agenda is design for composites, electrification, ergonomics, then the core modeling and productivity and usability. So those kind of things that, constant improvement of the Creo Parametric. And then we have a model-based definition, some news in there. And then if there's some time, we try to demonstrate some of those with the short snippets. At the end of the demonstrations, there will be a questions and answers section for you, where we try to stop and just that you ask more even depth in the questions and try to answer for them. So design for composites. This is a new thing for Creo Parametric, and it kind of requires totally new set of tools to be able to create components that are containing multiple plies, and how do you document those. So let's go and through that. So particularly where we are concentrating with this application, or PTC is concentrating with this application, is the products that are created with the manual layup of the fibers. So you kind of have fibers and which are looking like a mat or textile piece, and then you're putting them on top of each other. Then you impregnate them with the hearts, and then you make the hearts kind of go through a polymerization process where it will get hardened, and those textiles are embedded in there. And typically you are aiming for high strength and resistance to corrosion and very lightweight and durability. So what is needed then for the design these things? So it's kind of a schematics here. So first of all, on the top left, you have a design geometry. So you have to have kind of a surface which describes the outer surface of your geometry. What do you want to gain? And against that geometry, you start to lay up the individual textile layers. And on those layers, if you go for ply definitions, of course, we have to define which are the size, which is the material, and which is the fiber orientation. And the drop-off is simply meaning that how do they kind of if one mat is going over the other one, how is the edge, and the edges, how does the transition is going in there? And then you can control the individual plies by making the transitions between them. And if the roll width is not enough, then you might have to splice them. So basically have a two set of textiles in there instead of just one. And then the darting means that if you have to cut them in order to make them fit or kind of bend to the shapes. And in order to know where to cut and so forth, you have the draping simulation in the system, which then gives you a hint that, okay, how much deformation is needed for the textiles. Will there potentially be wrinkles or something like that during the placement of the textiles? And that's the draping simulation, what you do it for. And basically you control the overall system then with so-called laminate manager, where you can easily see that, okay, which are my layers, how does the system look like, if all the material definitions are correct, if you want to change some orientation, change the order of something, that's the way to do it there. And then as an outcome, you will get a solid laminate, with all the thicknesses and all that kind of deliverables. Then on the other hand, you need for manufacturing, you need the individual textile pieces to be cut out and indicated about the direction or the orientation of the fibers, and then the documentation as a drawing for a ply book. So all of this is included now for this composite design and manufacturing. And for how does it look, you will see at the top right corner some kind of fun snippet on the laminate structure. You will notice that there's different colors for each ply and each orientation. and one ply can be formed from the multiple kind of pieces. Then on the other hand, cross sections, which are quite interesting in this application, since individual layers of, for example, carbon fibers can be less than a millimeter thick. So if you try to see that, okay, how are my layers actually going in this product, it might be a bit difficult. Therefore, there is a specific cross-section functionality which enables you scale the thickness of the plies so that you actually can see that, okay, where if the geometry is as you expected, or if you just kind of missed one of the boundary curves and therefore the geometry is looking a bit odd for you. And then on the middle picture in here, you have this kind of draping simulation for the spherical surface. If you try to push let's say planar thing or planar piece of textile on that, of course, at the edges, you will start to get some wrinkles because the textile just had to orient itself. And at the end of it, what we do have, and also discussed on the last webinar, what we had was the Tuesday, there's also integrated structural analysis for this. So you can compute the defined composite parts directly in Creo Simulate, or put them in the third-party applications via specific export formats. So that's all kind of a new things what we have in there. So maybe we now jump a bit over this. Basically, this is just repetition, just showing the details of cross sections, just for the clarity. And also the draping analysis is pretty much the same thing. So just a repetition of those previously mentioned things. But the colors are representing the deformation, or basically the shear angle in here. So the red ones are the ones that most likely are causing you the problems during the manufacturing. But then this splicing and darting kind of a thing. So if you have, let's say, a shape that must be laminated and it's a 2 meter wide, but you still have a roll that is only 1.5 meter wide, it's all obvious that you kind of can't manage that with a single kind of ply or fabric. So you have to just, splice it. But then if you start doing multiple of them on top of each other, it starts to look a bit silly that you have one bump in the middle of the product. So you just might want to spread out kind of the overlapping point. So that is called stacker offset in there. And then this darting, which I tried to earlier explain, is kind of a tool that's meant to be cut triangular pieces off to help the deformation of the fabrics. So a lot of new tools and functionalities exist in there. I try to show this a bit at the end of the PowerPoint set just to make it a bit more approachable. But for me, it really looks like that PTC have provided a nice set of tools where you can instantly start doing a composite design, should that be something that is kind of relevant for your company. Then the second thing with what comes out of the Creo 10 is the design for electrification. So most of the companies are having currently all kind of IoT approaches, and automation is kind of getting more and more common. So therefore, you have to start thinking about how do we melt the electrical design domain to mechanical design domain. And the first kind of obvious point is that, okay, PCBs are in there, so printed circuit boards, and on the other hand, the cablings. Somehow we have to see them also in the mechanical design environment. So in the practical terms, how does it look like? Well, the Creo has had a cabling environment for the years, or let's say decades even. And today, what's been improved with that is that we have a new views, how you can see that what is actually the design content is. So if you have a multiple individual wires or multiple kind of cables, which are then possibly bundled together using shrink tubes or something like that, then sometimes if you just look at the design, it's quite hard to tell what's where and where does it go. So we have nowadays 3 different views available for for the cabling user, and you can find them on top of the model tree. So you can see there's 3 buttons in here. So first is cable view, then you have a bundle view, and then you have a connectivity view. And in cable, you just simply tell that, okay, if you click the cable, you will then know that okay, this is first of all creating all the cables for you. And then if you just start to drill down, it will say that individual connectors, where are they coming from, where are they going to, and which are the kind of the ports that they go, which are the colors that they have, and then on the other hand, which are the locations that they go through. So it's kind of all information on that one individual conductor of that cable is there available for you. Then on the other hand, you have this one state, which is then containing multiple cables and potentially multiple wires. And you get the same thing in there. You see that, okay, there's a one bundle which are containing these things. And what is the, for example, external diameter of that particular piece of harness, so that you can also start designing based on that. If it's a 10 millimeter hole, if it is needed for this particular bundle, or if it's 20 millimeter hole, that you can make the bundle go through. Then the connectivity view is obvious that first of all you have validation of harness, that if you have a connector which is then connecting two kind of components, which are the parts that are associated with it, which are the conductors that are associated, and which are the ports that are associated with it. So it kind of helps you drill down to design and validate it, that if it's correct and if all the connections are made. And it's really kind of suggested that if you are using cabling environment, this is the first tool that I would start, playing around and finding out that if it's very beneficial for you for the cabling design. Second thing with the cables is that we have now ability to split and merge harnesses. So harness is basically containing multiple individual connectors or cables, so those bundles. And then sometimes, what we actually do while we model is we are putting those location points where can you route those connectors or conductors. And you sometimes need to copy it to new name in order to make an independent harness of that one, and then you have independent harnesses. But now if you can split the one single harness to multiple pieces, it gives you kind of options to, hey, how about if I share the workload to a colleague who can do then a part of it, or how about if I'm just having a one subsystem and I'm just basically extracting it away, and that subsystem can also be optional, so that not everyone is necessarily purchasing it. Thus the product documentation reflects it's a bit better. And then if you split the harness, then of course you can merge it back together as well. So you can kind of go back and forth with that. Then when it's come to printed circuit boards, so far we have had this IDX standard or interface file format, something like a IDX version 2 or something like that. So electrical cats have been able to write quite a lot of data, but if the interchange format doesn't support it, then they are not available for the Creo Parametric. But now with the more recent kind of version of the interface, the interchange file, you are now able to see much more things. You can see solder mask, pass mask, silk screens, and all that kind of stuff, which you previously haven't been able to see. And then on the other hand, you can make them, have a different color on your 3D geometry so that they are much more visible for you as a mechanical designer. What on earth is going on in the PCB design? And how does it potentially affect you? Second thing is that when the electronics CAD are producing some kind of a hose or vias or something like that, so you can have a different kind of a hose for them rather than just a single type. So the ability is basically then to have an even deeper kind of understanding of what kind of a hose or vias are available, and then have use for them in the mechanical engineering as well. So all the parameters are now coming through a bit better, and you can customize the content in that called eget whole file, which then defines that how do they appear after the import of the geometry. Then something completely different. So human factors, basically. So what kind of sizes are human having, and do I read something or do I see something while I'm using the product? Or if I'm having an assembly line, how do I make sure that people are actually able to do the task that they are supposed to do? Can they reach the particular assembly or not? So today, this design for ergonomics is with all the Creo design license packages. So all the modern kind of license package contains all of the following that is coming off this slide. And only thing that you really have to do to make it run is to download the population datasets. So we have a mannequin library in there, which you have to download, which is not coming with the standard installation in order to make all of this work with Creo 10. So we do have quite a lot of new things in here. So let's jump all, rather than going through them in this kind of topic slides, let's just go through them. So first of all, you can place the mannequin with the connection. So what does it really mean is that if you want to, let's say, put a palm of the hand in particular, let's say the table, for example, then you can place that. But on the other hand, you can then say that I want to have a left foot in there and then maybe the right foot in another location, so that you can have it by kind of a constraints which are visible then in the model tree. And then those constraints are also available for you in the model tree, which then helps you to manipulate individual mannequins around. Second thing is that you typically have use cases where first of all you have a first step where the operator, for example, is doing one kind of a task, then he's doing a second kind of a task, third kind of, and fourth kind of a task. So it kind of leaves you to the situation where you either have to assemble multiple mannequins in the system, which then start to look a bit messy, or another way is to just have a single one, but if you can store the position, store the location of the limbs by snapshots, then you can use those and just have one mannequin on the system. And in order to support this snapshot, you can have in here we have a kind of a male custom, and in here we have male, maybe Japanese 95% of the size. So in here he's been put into two different locations or two different ways, and that is defined there. So he had two different positions. Then this fella is having two different positions, but on system when both of these are present, we have also the system level or scene level snapshot, where you define that, okay, now this individual fella is having the first one, and this is having the fourth one, the snapshot, but on the second one, you have a vice versa situation. So even more complex kind of multiple person kind of interactions can be now somehow documented with a bit better way with these individual snapshots and the skin level snapshot. Then the tracking has been, let's say, possible so far, but not necessarily so easy, since sometimes when you track, the whole body starts to move while tracking the just arm. And now there is a bit more control, but first of all, can we, how much do you want to move in millimeters? How much do you want to move in angles? So an individual kind of joints can be manipulated. And that's a bit kind of an improvement over the past one, if you have to really fine-tune the mannequin position. Second thing is that if you want to, for some reason, measure the joint angles, since some people do have limitations of how much you can and what is comfortable for you, or if you just have to, for some other reasons, know what are the angles, so you can measure the angles, for example, over the wrist in here, and you can store this measurement as well. So if you want to do some kind of analysis. Then this is pretty handy. You do have a reach envelopes now with each mannequin. So those green, purple, and maybe this is cyan color bubbles simply means that these are reachable with the arms. So either you can, visualize them with if you have an index finger, reach envelope, middle finger, thumb, or center of the palm, reach envelope. So what does it mean is that you don't necessarily have to position anymore the mannequin to all the potential kind of locations. It is typically enough that it is within a reach envelope. So it's possible for people to reach in there. And that kind of makes it a bit easier and faster to validate, for example, work shell kind of a design that, okay, I can reach all of these things within that bubble. Therefore, this design has at least, some kind of capabilities that it will work. And you can have them, with the right mouse button controls, or show them, hide them if they are distracting otherwise your design work. Then one thing, if you have had your mannequins previously, they are assemblies with multiple parts, and that is sometimes a bit messy when it comes to data management, since you can have, let's say, 2-3 different mannequins, so that suddenly you have more than 100 parts in your workspace, without then kind of cluttering it a bit. Now, all the mannequins are stored as inseparable assemblies, which simply means that you will just land with one single assembly file, and still it's containing all the parts. So one mannequin, one assembly file is what you see from this point on. So if you have earlier mannequins in your use, I would just kindly suggest that considering that, how about updating them for this inseparable assembly versions, so that you have a bit easier data management for this point on. Then we have something for this ergonomics, is also a visual field feature, which simply means that how much do I see from my surroundings based on your reflected object, like a mirror. So if we have a human eye in this picture, so as a star, so what is the visible kind of an area via mirrors in here? So this is kind of resulting kind of surface cone that really represents that what do you actually are able to see. If it's a human being, if it's a camera or some other sensor, that's a different thing. But it's still possible to visualize that early in the design change, and thus get a kind of a decent starting point from your design. And then for this, what you've been waiting for, I suppose, the core modeling improvements. Of what's there for me. So first of all, a slide that is not really, how would I say, not looking so nice, but nevertheless, let's put it in a different way. So if you have some issues with geometry, you will have now a bit richer description of what is the reference, what are the kind of fun components of that, or what are the individual kind of segments of your references, just to make it easier to track down the changes, track down the issues. Then the second thing is that with the offset tools, you now have a bit more broadened support. So previously, if you try to make an offset curve, you couldn't use a thing called all curves and features, which simply means that if I have a multiple curves here and there, I just can't select it with that. I just have to pick them one by one. And then second thing with offset is that I previously couldn't offset the construction geometry anyway. Now that is also possible. And then we have a bit of also enhancement with the trajectory-based features for curve pattern sweep and flange features as well. Then second thing is that centerline behavior. Sometimes when you dimension, for example, this circular hole or cut or recess in here and want to pattern it, and it's originally been dimensioned with the, let's say, centerline and centerline angle, and start patterning it, sometimes you do get unexpected results, so that geometry will just start to jump or flip around, which is not really expected. And on this Creo version, there has been some work done for that it doesn't flip anymore. But let's say put it into test, and then you will know that how much better that is. Bit hard to demonstrate, and also that how do we know that. Then there's a new tool consolidation. This is particularly handy with multi-bodies. So if you are modeling, let's say, that kind of a screw tower or whatever you call this thing, and you are also putting that, for example, as a library component and just throwing it in your model using UDFs, and now you just want to melt it into your existing geometry. What do you have to do? Previously, do you use the solidify or some kind of offset replace kind of approach for it? But today you can use it split or trim command for it. And difference between these really is that split, if you use that option, it is simply cutting this body to half. So you will resulting is both of them. But if you use trim option, then the surface that you select as a reference is used as a cutter, and you can select which side do you want to keep. So it's just the consolidation of that feature, and it kind of improves the overall workflow by just making it available on a single button that you can now play around with the bodies. Second thing with bodies is that we have a thing called Boolean propagation. And if you look at making Boolean operations, so you have this casting or forging first, and then you have two pieces in here as a cutter. And these are containing two things now. They are containing colors and PME annotations. So basically 3D annotations for the geometrical tolerances or tolerances. So if I subtract this geometry out of that, this is what you get today. So you will get that appearance propagations, but also you can get this annotation reference propagation. So this cutter can have a tolerance which is then transferred to resulting geometry. So it's not going away. And this, of course, makes a model handling a bit easier. You understand that, okay, this is the color of the cutter, therefore it's cut by that. So you kind of get better hang of your model and modeling practice that. But then on the other hand, if you have this kind of a cutter part, which is specifically made, which is containing all of its tolerances, and you're using an external kind of a copy, push it into place as a library component, and then just pattern it, what is happening is that you get all of your geometrical tolerances, all of your kind of fun surface quality markings, colors, and whatnot in your model. And this can be quite handy for using kind of external cutter parts to be model some geometry, and specifically if they are standard kind of openings, like some connector ports or something for the electronics. Then with the divide and unify surfaces, what we had in Creo 10, well, if you just have this kind of a component and then you just get this kind of box and say divide surfaces, and by clicking the top one, what is happening is that with Creo 9 is that it will only count the ones, or divide the ones that it touches. And for these 5 surfaces, it's a bit odd situation since it's within the box, but it's not touching, therefore it's not kind of a part of that new surface, even though somehow logically it should be. But with Creo 10, the idea is really that if it touches, the border is touching, or it is engulfed by that one, therefore it's a new surface. So resulting object in here is that the red ones are one surface ID and the yellow ones are the second surface ID. Then on the other hand, I have a second bit per slide on the next thing in here is that if you have this kind of let's say extrusion or kind of a bump in your model, and you want to transfer that or move that using a flexible modeling, which is, tracker is shown here, basically you just start tracking, and now it's 15 millimeter plus away. Then the question is, what will happen to this divide surface, which you saw also in the previous slide. So that will then remain, but still you have some stripe left in here. Using that move command in the flexible modeling usually causes that these rounds are auto-generated for you. So there's no kind of a continuation of the divide surfaces, but all the risk surfaces that had it are still keeping it. So somehow we try to make your changes a bit more kind of understandable while using the divide surfaces. Then the patterns in Creo, especially if you pattern the pattern. So in here, if you look at the geometry, what is happening here, you have one cut geometry, which is then rotated 4 times around the axis. And then the next time you have a bit more of them, bit more of them, bit more of them. And just, this is the first is pattern, and then you pattern the pattern outwards. And now the question is, how do I somehow control the count of these secondary level patterns? And the answer is now that today you can have quite a lot of the ways to control them. First of all, you can have relations where you control how many of them will be. So, for example, in here you have a pattern which is controlled, the amount of them controlled by relation. Then on the other hand, you can do a datum graph feature, which looks like this. An idea is that when the geometry is going forward, you always pick up the count from the y-axis, and therefore your pattern can't start to change. So that is kind of the thing now, that there's a bit more control for your pattern of patterns available. Then there are some cases where you have, let's say, a hole which is then patterned around axis with 8 individual instances or 8 individual kind of occurrences, but you are manually clicking 2 of them off. So question is, how many patterns members do I have? And with Creo 9, if you ask the system how many pattern members do I have, it will tell you 8, even though you've been suppressing 2 of them manually off. And now with the Creo 10, you do have a pattern parameters in there, which say that pattern actual members and pattern total members. So these are basically taking account of it, that if you have to, for some reason, like a bill of material reasons, tell how many of these I will have, you are having access to parameter which reflects the correct total value rather than a potential value of how many there could be if you wouldn't be suppressing some of them manually. Then one of the features, new features for the Creo Parametric as a basic kind of a core functionality is that in order to make that composite design work, we sometimes need curves which are projected to the surface of where we do the layup, and you just have to take part of them. And in order to make that happen, you have to have a kind of a closed loop for the upcoming slice. And now we have this thing called closed loop curve. So what you do in here is you basically just pick up curves that you want. For example, I have a reference, is all curves in feature chain. I have one sketch that contains 1, 2, 3 curves, and then I have a surface change basically at this box. And then during the creation of the closed loop curve, I can go through the next solution. So this is the one closed loop solution. There's a second one. Here's a third one, and there's more of them available. And then you just cycle through of the one that you need. And even though this is kind of a developed for the composites, this is available for you all if you have to do this kind of fun helping geometry sketches, which you then later on are utilizing for your further design job. Then general kind of productivity and usability enhancements, what we have. I'm just looking at my watch and wondering how much time do I have. Tracking the components in model trees, so basically reorder the assembly components, has sometimes been a bit problematic, since you can accidentally drop the individual component to one of the sub-assemblies without you to notice. And therefore, your top assembly, of course, is changing, but also your sub-assembly is sometimes changing because of that. and you sometimes get lost of those components totally. Hey, where did they go? So now we do have a new Configure Pro options that disables basically dropping the components accidentally to sub-assemblies. It really has a confirmation dialog for you. Do you really want? And also there is a time delay that you really have to hang over the sub-assembly for a few seconds before the actual dropping can occur. So therefore, what this results is a bit better management of the assembly, so reordering the components and restructuring if you want to change the components between the assembly levels is possible. And now it's kind of this drives a bit more kind of if you want to change the assembly level, yes you can, but you really have to confirm therefore that your references are also taken care of. Then second thing, for the guys that are really doing this lot of surface modeling, there's improvements with the quilt body evaluation tree. An idea with this thing is that, first of all, as an outcome of this kind of a surface, you just have a single quilt. But now tell me which kind of a quilt it was formed and in which order. So if you have this quilt body evaluation tree and click this one on, it simply means it just automatically shows the snapshot of the quilt. And then I click that one. It simply says, okay, this is the geometry, how it looks like, this is the location it is, but also it is based on quilt number 1, quilt number 2, which are then created with merge number 4, merge number 7, and they are combined together to make this thing happening in the merge number 3. So now it's kind of obvious that, okay, hey, by the way, I want to change this corner now. Where do I want to go? It's quilt number 1 or quilt number 2, which one? Just click one and then you know instantly. So if you happen to have a surface model with, let's say, up to 5,000 features on it, then sometimes you totally get lost of track that, okay, what did I do at which point? And this really helps you to make that happen, to understanding your model a bit better. Second thing with this is that, yes, we do have this quilt body evaluation tree, but then on the other hand, we have some other trees as well. We have a design tree in there on top of. So if this was the model tree, standard one, this was the previous mentioned quilt body evaluation tree, but then we also have a design tree. So if you start thinking about, okay, why do I need design trees? Well, sometimes, for example, the feature order in the model tree is something, and then you can make a local groups. But let's say that the group 2 and group 6 would be nice to have one central kind of design importance. So I want to somehow highlight them in model. I can't put them in the group since they are not in consecutive order. And sometimes it's even impossible to do it like that. So we can use in certain extent to communicate the model structure, the groups, but sometimes you can't. And therefore, if you have these folders or basically design objects, so you can say that, okay, if I want to make a pocket quilt, I can also have this quilt and this quilt, which is taking part of it. And if somebody's trying to later on try to understand what is the model structure and how it is done, and what is affecting where, you can look at these folders, which are not dependable on the modeling order. And today, what you can do beyond the Creo 9 is just take a quilt body evaluation tree and just drag to these folders. And therefore, you can document your designs a bit better way. And also, this will help you to find out the key kind of features and the bodies and the quilts for your design. Second big thing with the surface modelers are that if you manage to find your quilt, what you want to modify, and let's say it's a quilt combination of something, and I still want to tweak it a bit, you can hit it with the right mouse button and state to insert the quilt. And what is happening in the model tree is that it activates the insert mode after the last contributing feature of that quilt, and then you can model it, and then you can say that, by the way, bye-bye, exit insert mode, and then it is returned to original state. And same thing goes for insert body. So if you're picking the body, the same thing happens as well. So you can also have multiple bodies, and similar thing that if you click the body and say to insert the body, and then the system is automatically jump to last feature. That is kind of responsible for creating the body, modify that, and then get back in. So jumping back and forth to particular point and of time in the design history is much easier now. Then the model-based definition. Let's have a bit of faster pace with this, since I think I'm running out of time otherwise. So what you can do now is attach annotations to other annotations. Simply meaning that if you happen to have a surface, flatness tolerance like in here, 0.6 millimeters with respect to base datum A, you can also attach the surface finish requirement to there. And if you move this one of these, second will move as well. The similar kind of a thing that what you have had in the 2D drawings for the years and years. So now it's available also to MPD annotations. Then we have a G&D advisor, which basically helps you create those geometrical tolerances. First of all, they are binding rules, but second of all, they kind of tolerate all the kind of fun key geometry of your design. So today we have a user interface changes where the tolerances are a bit better shown, and also your differences are a bit better shown. It's a bit more visual, and also there is some new features like all the surfaces that you have not specifically specified with some other tolerances, like let's say in here we have some perpendicularity, and in here we have some shape tolerances. All the other surfaces which are in the dark red are automatically collected to within the general tolerances, general profile tolerance. So it kind of makes you sure that you didn't lose anything while you tolerating the pieces. And then there's general kind of enhancements, like there's a new hole types in here, and the system is trying to recognize them and giving you the best possible tolerance scheme for that one. So you have now support of more of those. And second thing is that object action is now working better than ever. So you can also now, before you even decide what kind of a tolerance you made, you can design the geometry and then say, this is the tolerance I want to make. And previously it was on other way around, that you want to say, this is my tolerance, and then it's applied to that geometry. So object action object kind of both ways goes today. Then the last slide, I think, for my 45 minutes is the support of AP242. Step translation now gives you more support in geometry. So we are pushing more and more data to the step file to describe what is the dimension, what are the surfaces affected to it, so that the downstream applications can really benefit of that richer and richer description of the MPD annotations. And it is therefore easier to create, for example, inspection tooling paths, so coordinate measuring system paths based on that richer information. And also, if you happen to have subcontractors who are not really using your own in-house windshield system, and therefore not really can't really get all the details of the design requirements, this will now help you to kind of supply a bit better information for them as well. I think my time for Q&A is pretty much now. I promised honestly on the last presentation that, hey, there was a questions which I didn't know answer. So I want to use this moment to give you an answer for that question. One gentleman kindly asked me that if it's possible with the Creo answer simulation to use bilinear plasticity, large deformations and cells all together at the one go. And yes, it's supported. And as you can see, it's shown here. We have a mesh, we have a load case, and then as an outcome, we have a first principal plastic strain shown as a result. So it plays all nice together. Any other Q&A questions do we have?
We don't seem to have any questions at the moment, so I think we will wrap this up. Thank you so much, Mikko, for a great presentation, as usual. It's always nice to see your CAD magic.
Thank you very much for that.
Thank
you everyone for nice participation for this one.